Hey guys, I wanted to make a video real quick to help answer some questions on the finding the function using regression worksheet that's due on Friday. One thing I want to talk about first is when you make a valid or an accurate prediction, your prediction value should be close to the observed value. So what I mean by that is if I were to come down to this scatter plot right here and I find my regression equation, if I predict the wind chill temperature for a wind speed of 15, the answer should be close to 0. I shouldn't predict a wind chill temperature at 15 and get something like 200 because that's nowhere close to the observed value of 0. So prediction values should be close to the observed values. And the other important thing, super important about making valid predictions, is predictions are valid only for the range of data used to estimate the model. So what I mean by that is the wind speed here goes from 5 to 25. So I can go a little bit below that and a little bit above that when I make a prediction. Like I could make a prediction for a wind speed of 3 or a wind speed of maybe 30, 35. It's not too far from where I am. But if I try and ask you to make a prediction for a wind speed temperature of 80 miles per hour, well, 80 is very far outside of this data that I'm given, and so data that far out might not be true anymore. And that should make sense if you're talking about, wind speed in miles per hour. When you see a wind speed of 80 miles per hour, that does not happen very often, and normally it's in like a hurricane or a very severe weather situation, and so that might affect the wind chill in a different way. So your predictions are only valid for, close to the range of data that you have. All right, so what this first question here, actually I already have the answer there, but what type of correlation does the scatter plot show? So the reason that I'm doing this particular problem is because on the finding the function using regression worksheet, which is your homework that's due Friday, it says, for each set of the data below, perform regression on your calculator and find the appropriate function that best fits the data. Choose from these. And you have 6 different choices there. So this does not mean that you have to do all 6 of these models for every single data table that you have. What it means is look at your scatter plot and choose 1 or 2 that you think would be a good fit. So I'm going to go to Desmos here. Okay. And I'm going to add a table with this data. So this data, the x values are 5, 10, 15, 20, and 25. And the y values are 7, 3, 0, -2, and -4. So I'm going to change my window here so that I can see all those values. So if I ask you, okay, what type of correlation is shown here? Well, this data here looks pretty close to a line. So because this data looks close to a line, when it says what type of correlation does it show, you'd say, okay, it shows a linear correlation, and in this case, that correlation is negative. Okay. All right, so because this data looks pretty close to a line, I can pretty confidently say, okay, if I estimate this using a linear regression, it should be pretty good. So my R is -0.98. That's a strong negative correlation. Now, it could be if I tried quadratic or cubic or quartic, I might get a R squared value that is closer to 1 than this R squared value here, but because the data is pretty close to a straight line in the scatter plot, you're fine if you just use that. And if you use that, you can say R equals -0.987. What you don't want to do is something like this. Okay. So find the equation of the regression line. We found the linear regression, and it says predict the wind chill temperature when the wind speed is 30. So let me make sure you know how to do that. So if you came over here, your A is negative 0.54, so you would have negative 0.54 times 30, plus your B is 8.9, and if you did that, you get 7.28, and if you go back here, and you look at this data, predict the wind chill temperature when the wind speed is 30. So, oh, it's because I put in 3. Negative 0.54 times 30 plus 8.9 is negative 7.3. And if you go over here, that looks pretty close to what I'm seeing. At 25, it's negative 4. So at 30, it seems to be going down here. It should go down a little bit, and it does. Okay. So then it says, would it be appropriate to use your equation to predict the wind chill temperature for wind speed of 75 miles per hour? Well, that's kind of far outside the range of data that I have, and so you would say no in that case. So the reason that I showed you that, and this is what you don't want to do with the homework that's due Friday. So if I'm looking at this data, so now I'm going to type this data in. So if I type in, here actually I'll just get rid of this, and get rid of this, and get rid of this, and I'll insert a new table. And so I would have 88, 78, 62, 75, 95, 91, 83, 86, 98, and then my Y values 81, 80, 55, 78, 90, 90, 81, 80, and 100. So what I'm going to do, I'm going to fix my window. And my X values here seem to go from, let's see, 62. So maybe I'll go from 50 to like 110. And here on for the Y's, maybe I'll go from, 40 to 110. So if I look at this scatter plot, it has some curves in it. So what I don't want to do is say, okay, let me do a linear regression on this. And okay, I'm just going to stop there. Well, I have an R of 0.944 and I have an R squared of 0.891, but because this has curves in it, there's a good chance I can do a lot better than this. Okay? And so what I would do is I have this little reference sheet that I gave you guys a while ago. And let me see if I can bring this up here. And if you remember on this regression sheet, I said, okay, here's a scatter plot for a linear regression. Here's a scatter plot for a quadratic. Here's one for a cubic. And so I'm going to look through these and say, okay, which one of these kind of looks like the graph that I have, the scatter plot that I have? I think cubic. So I'm going to try that. Okay. So y1 is approximately equal to ax1. And I'm going to raise that to the third. Plus bx1, I'm going to square that, plus cx1 plus d. So if you look at that, I do get an R squared of 0.9748. That's a lot better than the 0.8921 and the 0.9445 that I have there, and it more closely hits the points in this scatter plot. And so one thing that I do want to make you aware of, sometimes if you try like a quartic, for example, so ax1 to the fourth power plus bx1, and I'm going to raise that to the third power, plus cx1, square that, plus dx1. And then I'm going to say plus f because e is an actual number. Okay, so in this case, you'll say, well, this r squared is just a little bit better than this one. Well, what happens is, you start to get numbers. See this 0.00003? This a is really, really close to 0, meaning, okay, a cubic is probably okay because the number in front of the fourth power is really, 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 really super close to 0. So if you used a cubic, that would be fine in this case. And so you can look at the scatter plot and say, hey, I think that looks like a cubic. If you said quartic, like it's not wrong. It's just that a value is so close to 0 that the cubic is just fine. So I guess what I'm saying is you don't have to try, like if you think, okay, I think this is a cubic, you don't have to try a linear, a quadratic, a cubic, a quartic, an exponential, and a logarithmic for every single problem for your homework. What you're going to do is you're going to look at that scatter plot and say, okay, what type of correlation do I think this might be? And then maybe test a couple of those and see what you get. So let me give you an example from your actual homework. So if you're looking at let's look at number 4, for example. Okay, so the data on your homework for number 4, you have 2, 4, 6, 8, 12 for your x values, and you have 10.4, 10.6, 11, 11.3, 11.6. So let me change my window so that I can see these. So my x's I'm going to take from 0 to like 15. And my y's, maybe I go from 10 to 11.8, and I'm going to go by 0.2s. All right, so this looks like it might be, it could be kind of close to a line. So I could try a linear in this case. Whoops. And you'll notice I get an R of 0.9828. That's pretty good. So that's not a bad model. Maybe I could get a little bit better because it looks like it might curve up a little bit here. And so if I go back to that regression that I have, I said, well, maybe that kind of looks like it maybe could be a logarithmic regression. So maybe I'll try that one and see which one of those is a better fit. Whoops. Okay. So in that case, actually that's a worse fit. I get r squared is 0.9475. And I say, okay, well maybe I'll try another one that looks like maybe it'll be a better fit because it has a little bit of a curve in it. But if you left and you said, okay, well it kind of looks close to a straight line, I think linear is okay. So let me give you an example. So we'll try one more. Maybe we try quadratic because it looks like maybe it'll kind of curve here. Okay. But you don't have to try all 6 for every single problem. You're going to look at the scatter plot and kind of see what you have here. And that says 0.9849. So that's the better fit, the quadratic is. You can see it. It's in this green color. That's not the line. Comes closer to the data points. So you could say, okay, I'm going to use a quadratic model for that one. Okay, but if you'll notice again, this a value in the quadratic model is pretty close to 0, which is telling you the linear model is probably pretty okay for this particular set of data. So let me do one more. Number 1. So this is number 1. Okay, So let me fix my window here. My x values go from maybe 0 to 20. I'll put my y values from 200 to 5,000, and I'll let them go by maybe 100. Okay, so because I already have these equations typed in, it gives me this data for this particular problem. But if I were to take this out, this data definitely looks like it has a curve. So if I'm looking at my scatter plot notes again, oh, that's not it. My regression type, my notes again, that has the scatter plots on there. Okay, I'm looking, and I'm going to say, okay, well, maybe I'll try quadratic because that could be part of a quadratic or part of a cubic. Maybe I'll try an exponential, but I know it's probably not going to be linear because it curves. So then I would try a couple different ones. Do I have to try every single one of the 6 that's on there? No, but I want to try ones that closely, if it's curved, I want to try some of the scatter plots that are curved instead of just linear. And you'll notice in this case, if I tried linear, I get 0.94, but if I try something like exponential, okay, I get 0.9973, and that's much better fit for this data. So hopefully that helps answer some of your questions on that.